स्टूडेंट्स लाइन कोडिंग की स्कीम्स को डिस्कस कर रहे हैं. हम लोगों ने कुछ स्कीम्स जो हैं वो यूनिपोलर और पोलर लास्ट टॉपिक्स में डिस्कस की and we'll carry on with the same discussion. Students, as I told you, we discussed the NRZ, unipolar NRZ scheme. We have spoken about polar non-return to zero. We have discussed polar RZ, which is return to zero, and then biphase as well, which had two variants, Manchester and differential Manchester. Let's discuss the bipolar, AMI, and pseudo-ternary now. Students, to get rid of the disadvantages that we discussed of the bipolar techniques that we discussed, bipolar, biphase Manchester and differential Manchester, we came up with these two bipolar schemes, which is AMI. AMI is nothing but alternate mark inversion, and the mark word, students, it comes from telegraphy and it means one. Students, AMI therefore means alternate one inversion. So if you follow the pattern out here, you'll see that your zero stays at zero voltage. This is neutral. And then we do an alternate inversion. This is important. Please notice we do an alternate inversion for ones. So for the first one, we will go to the positive side and we'll assume a positive voltage. For the zero, we are neutral. We stay at zero. We stay at zero. For the next one, we are going to do an alternate inversion. For the first one, we represented that one with the positive voltage. And so the second one is going to be represented by a negative voltage. Once again, we have got a neutral or a zero voltage representing 0 bit. If the next bit is 1, for example, then because we are doing alternate mark inversion, alternate one inversion, the first one was positive voltage, the second one was negative, and therefore if the next bit is 1, we will again go and represent this by a positive voltage. So in this particular case, our ones are inverted, but our zeros are neutral or they stay at 0 voltage. Students, pseudo-ternary is opposite. In this case, we invert the zeros. So in this particular case, the first zero is represented by positive voltage. 1 is neutral or 0. The next 0 is represented by a negative voltage. Now the next 0 is, there is a 0 after a 0. So the next bit, which is a 0 again, it has to be represented by a positive now. We have to invert. So we go up and represent this by a positive voltage. Once again, coming down, we have got a 1, which is neutral or 0. And then, because our last 0 was represented by a positive voltage, this 0 is going to be represented by a negative voltage. Students, in this particular case, the advantages in this case are that there is no DC component. And the signal rate is also the same as NRZ. So basically, no DC. And we have got a signal rate which is equal to NRZ and better than our bipolar Manchester and differential Manchester schemes. Since AMI, alternate mark inversion, is commonly used for long distance communication, but it still has a slight synchronization problem when the long sequence of zeros are present. So students will see how we can use different techniques. One of those techniques, we have already spoken about that, is scrambling. This is a particular case where the technique of scrambling may be needed to fix the synchronization problem. Students, by discussing all these techniques, the basic desire is to increase the data rate or to decrease the required bandwidth, as I've told you before we started the discussion of line coding. So students, to achieve this goal, there were multiple experimental or multi-level techniques that were introduced. There are more than one that are given in your book, and you can have a read. But we are going to talk about one of them, which is 2B1Q. Or in other words, we have got 2 binary, 1 quaternary technique, 2B1Q. Students, in this case, what we are doing is we are using a data pattern of size 2. 2B, 2 binary, data pattern of size 2. And as you can see, we are encoding a 2-bit pattern as one signal element. So we are using one signal element to carry 2 bits. Now students, in this particular case, because it is quaternary, quaternary means quarter, means 4, we have got 4 different levels. Students, what's happening in this particular case is that for each of the 2 bits or the signal element, we represent this by using a rule which says that if we have a combination 0, 0, we are going to represent that by a voltage level which is -3. If we have a 0, 1, we are going to represent this by -1. If we have a 1 and a 0, we will represent this by a +3. And similarly, if we have a 1 and a 1, we can represent this by a +1. So you establish these rules in such multi-level 2B1Q scheme, and then you use 4 different voltage levels to represent 2 bits per signal element. Students, in this particular scheme, the 2B1Q scheme, it actually gets rid of quite a bit of the DC component, and there is seldom a synchronization problem with this one. And so this scheme is majorly used in the DSL technology, the DSL modems that you have at home that you use nowadays to connect to the internet. So high-speed connection to the internet using the DSL lines, this is what you use.